Hi guys, it's Warwick here. If you have been watching my channel, you've probably seen that lately I put up a tutorial on how to do a RedPower2 frame lift, i.e. this guy. Now also in the description I did promise on how to make a multi-floor elevator. Basically it's just several of these for how many floors you need minus one. But then there's also going to be a ComputerCraft component which will actually do the control mechanism, so a call function. So if you're on a level where the lift isn't, you press the call button, it will come to you. Let me just get a actual framework set up off camera, and I will be right back. Okay guys, I'm back. Just finished building this impromptu multi-level setup. I've got my lift here, and I've got, just to make it easier, I've got the amount of space between each level even. It just makes it a bit easier for when you set your circuits up later. And then you'll also notice I've already pre-set up 4 buttons here on each level. Now this is level 1, so we have a button to go to level 2, button to go to level 3, level 4, and call lift. So say for instance if someone got off at level 3 and you're in level 1 and you want to use a lift, you just press the call lift button and it will bring it down to where you, or the level on which you press that button. That's all controlled by the ComputerCraft stuff we'll get into later, but just wanted to show you what the base setup looks like. This is a working sample at the moment. When I don't actually break the motors, might help. I've got 101 for down and 100 for up, so we put that there. We use our little orientation trick I told you about in the last video. Okay, so 100 is up, and because the bigger side of this black notch is upwards, so that's going to go up for us. And when you design this, you got to take note of how many blocks it has to move between each level, between 2 levels, and between all 3 levels. So you'll see what I mean here in a second. So say we want to take note of how many blocks it has to move to go from level 1 to level 2. So I will set this to go up. So it's 4. So because I've also already set this up to be the same all the way through, I can automatically assume that from ground level to level 3 is going to be 8 blocks, and ground level to top level is going to be 12 blocks. So if we take note of that down, we're going to need it for the next step, which is creating 3 of these circuits here that I showed in the last video. And what they're going to do is you're going to have one that will move the lift between one level, you're going to have one circuit that will move between 2 levels, and then you're going to have one circuit that will actually move from top to bottom, so 3 levels. So I will get these circuits built and I will be right back. Okay guys, I'm back again. Finally built these circuits. Now you will notice that these 3 are identical, so they're exactly the same, but the main difference being is on these counters. So you'll notice our maximum count and decrement is 12, so that's the distance it takes to go from the bottom level to the top level. So this circuit is for the movement between those 2 floors only. This one, max 8, decrement 8, so that skips a floor. So say for instance if I'm on level 1 and I want to go to level 3, that's what this one is used for. And then this one is max 4, decrement 4, so this is between the adjacent floors. Now just to give you a demo, if we'll say go from where it is now to the bottom floor here, we will flick this over to make sure it's in the down position, which I've got these named. So it's in the down position, and we'll let it roll. Okay. Now, another thing you might notice is, compared to the last set of circuits I showed you in the last video, I don't have a wire running here from the output of the counter to the toggle latch to change direction when the circuit's finished doing its thing. The reason is, I want it to be set up so that my actual ComputerCraft computer controls whether it goes up or down. The main reason being is because of this button here, the call lift button. What will happen is that when you press that, the computer will decide, okay, does a lift need to go up or down depending on where the lift currently is and what level the button was pressed. And then the computer will then decide whether it needs to go up or down, and it will choose which circuit it needs to run to do so. So this is the circuit. If you want to know how to make that, it's in the last video I did. Also, I'm using wireless redstone for pretty much everything here. You can use normal insulated wire and bundle cable and whatnot. I have used that setup in the past. It can get a little more complicated trying to figure out which wire does which and so on and so forth, so that's why I'm using the wireless redstone. Okay, and this bundled cable here, that is our input for our circuit, so this will end up being connected to our ComputerCraft computer. Okay, so rightio, so what I'll do now is I will place down my control computer, so to speak, get the rest of this wired up the way I want, including the transmitter for these things, the direction changes, and I will be back. Righto, back again. As you can see, I've been a little bit busy, apart from just the computer. Now, you'll notice I've got this white bundled cable coming into the left-hand side of the computer, and just another type of bundle cable. This can be any color bundle cable that you want, just as long as it's separated from the rest of the system. This is going to be our button input for our lift. Now, yes, this is a lot of inputs. I've found that this is probably the easiest way for me to set it up. Surely this isn't the most efficient way of doing it. I'd be very surprised if it is. So if you can make it more efficient, please do let me know, because there's a lot of resources involved in this part. But as you can see here on the signs, I've written what each one of them does, and I've given each one an individual frequency, and they all go into different color insulated wire. Now, this system has what I like to call an easy limit of 4 floors, mainly because it uses all 16 colors for the 4 floors. Now, I'm pretty sure you could actually set up another bundled cable coming off here and another set of inputs for it. That would require myself or someone else who is keen enough to modify the code that I'll supply for this to actually include it. Anyway, and also on the signs here, you'll notice that these numbers, these are the bit values for each color of the wire. I like to put these up on these signs just to make it easier for when I'm troubleshooting, because the program that actually monitors for when these receive a signal uses the bit values, not the color names. I will show you that in a little bit, but pretty much if you can replicate this kind of setup, this will work for the code that I will supply for the tutorial. I will put a link to the description for the complete set of programs that will go on your ComputerCraft computer. I will also try and set up a group of pastebin links, so that if you have HTTP enabled on ComputerCraft, or either on single player or on your server, you can use the pastebin get command to download the programs directly to the computer instead of having to type them in by hand. When I typed them in by hand, it took me forever. So if you can use that, that might be a better option for you. So the next step is, I suppose, setting up these transmitters that will actually go behind these buttons to set them up. So we're on level 4 at the moment, and this is going to be our level 4 to level 1 button. So you'll also notice that I've named all of these, or all of those individual frequencies on that wall, so that instead of having to remember the numbers, I can say, okay, well I'm on level 4, this button needs to go to level 1, so I can say level 4 to level 1. Screwdriver. So that's level 1, 2, 3 and call. So level 4 to level 2. Level 1, 2, okay, level 4 to level 3. And call level 4. So that now, if I were to press the call lift button on that bottom floor, it will come in on this one. Simple as that. You can wire this up hardwired with cables if you want. I have just found it a lot easier to set this up with a wireless redstone if you have the resources for it. Also, another note, just something while I can think of it, if you don't have the horizontal space for these circuits to be laid out like this, if you're clever enough with covers, you can actually stack these on top of each other. I have done it once. I did have mixed results with these pistons, especially if they're sitting on top of each other, but I'm assuming that if you leave a space in between each level and then put covers and put everything on top and so on and so forth, you can actually fit this in on the, what is it, 10 by 3 footprint, but then you make it so it'd be 8 or 9, no, it'd be less than that, 6 or 9 blocks high for the entire setup. So anyway, I will get all of these transmitters put in and configured, and I will also start getting the direction changer input onto, it will come off the back of this computer, and I will be back. Okay guys, back again. I have finished setting everything up. A couple of things you'll notice from the last segment is this bit here. This is our detection for whether it's going up or down, so the computer can make up its mind whether it needs to go up or down. And this output here off this bundled cable, I've used yellow because that's a colour specified in the code. It will actually change the direction if need be. So what I'll do is I'll just take this disk out of here, my breaker disk, reboot that. Now to see if all that hard work has paid off. So currently that lift is all the way up on the top floor. I'm on the bottom floor, I need to get on, so hit the call lift button. And then cross your fingers, it should come all the way down. Imagine that. Okay, we're on the bottom level. I want to go to level 2. So we press that button, and you should see our middle circuit running over there. And we are on level 2. Fancy. Okay. Now for the guts of the operation. So I'll reboot that with the disk in there. It basically stops that startup script from running. Okay, first things first. The script that monitors which button has been pressed, so which of any of those 16 buttons have been pressed, is the startup script. So we'll go edit startup. And you remember these, I was talking about these bit values earlier? Well, this is where they are. So pretty basic explanation is this sets what side is the button input. This side sets what the actual output is to kick the circuits into gear. So what happens here is it watches basically a big if then else statement. If 1, which is white, comes in, then it needs to run the call bottom script. So that is our white input, so if you press that, it's going to call the lift to the bottom. Now, yes, I do know that here I've called these levels, and on here they're called floors. That's because this set of programs was actually written before I made this video, but they still apply. So as we go through here, we've got one else if statement for each color. Then else it'll just wait and put itself back into a loop. Okay, next thing is, these are all the scripts here by the way. Next thing is our individual movement programs. So whether it needs to go, say, from floor 1 to floor 2, or say floor 1 to floor 3. So we'll check out floor 1 to floor 3. So edit F1 to F3. We've got our inputs again. So input side is right, which is this side. Output side is left, which is this side. And there's another one here called UDS, which I've called up down side, which is at the back. So I set the variable to check for a redstone signal on that insulated wire. That can be any color, by the way. Created a function, or hang on, set a variable called H. What it does is it opens a file called counter and opens it in write mode, so the script can actually write data to that file. The reason why we have this counter file is so that the system knows the current location of the lift. So at the moment it is at level 2. So what happens is that if I hit any of the buttons here, it will check that file, it will open it up, it will check, okay, well I'm currently on level 2, so I need to run, as it says here, 2-floor drive. Now I have a 1-floor, 2-floor and 3-floor drive. So 1 floor is just 1 floor, 2 floor is 2 floors, and 3 floor is the whole 9 yards. So what happens here, this is the floor 1 to floor 3. It writes where it's going to into that counter file so that it's ready for the next button that's pressed. And now this while true do, this is checking whether the circuits are either in the up or down position. So if the input is true, so if this is emitting a redstone signal, then just run the drive command, because it's going from higher to lower, so it needs to go down. See, these aren't emitting a signal, so that statement is currently false. So this is where our else comes in. It will pulse, or it will use this function called pulse to send a redstone signal, just a very small pulse on the yellow cable, which is this one, which will flick all of these over to the other way, and then run the drive command, or the drive script. Okay, we'll exit out of that. Okay, that's our floor movement 1. Now these drive, so we've got our 1 floor, 2 floor, 3 floor drives. So if we edit our 2 floor, oh, helps if I actually spelled correctly. Local variables again, a function, our pulse function, and then it says here pulse colors.orange, because our 2 floor drive requires this to drive the lift 2 floors. It requires this circuit to be running, so that's our orange input here. So our 1 floor drive will have a white input, 2 floor will have orange, and 3 floor will have magenta. Pretty simple. And then when it's finished, it'll go back to monitoring button input. That's after it's finished driving the lift. Okay, now for the fun bit, the actual call buttons. If we have a look here, I've got a call program for each level. So call bottom is obviously level 4, level 3, level 2, level 1. So if we edit our call bottom, now I did use io.open in the other ones. I don't know why I've used the 2 different types. They both work. So what happens here is it pushes the contents of this counter file into this variable, and then it compares it and it says, okay, if the counter says it's on level 1, then run the script floor 1 to floor 4, or level 4, or level 1 to level 4. Well, that actually just prints it to the screen. Let me know which one it's running, and then it will actually run it, and then so on and so forth. So if the counter says it's on level 2, then run level 2 to level 4. If it says it's on level 3, then run level 3 to level 4. But if it's already on level 4, it'll just pretty well ignore it and just go back to monitoring for input. I think that's pretty much it. I will upload all of this to a zip file for you guys to download. As I said earlier, I will also try and put all of these into pastebin links. Because there's quite a few there, I'll probably put all the pastebin links into a text file. Same locations where you could probably actually download them. I'll also put up the world save for all of this, so that you can download it, open it up, have a bit of a tinker around yourself, see how it works a little bit in more detail. Take your time with it. Just a note, I am using the FTV Direwolf 20 mod pack, so that you will need that to open this world save, or otherwise you'll have problems. Righto guys, well I hope you're able to learn something new from this. I also actually hope you're able to follow along with me rambling for quite some time about stuff you probably didn't need to know about this setup. If you do have questions, please write a comment on the video, or just send me a message on YouTube. I'll be more than happy to answer your questions, although sometimes I do get a bit lax to actually getting around to answering them, so if I don't reply straight away, don't worry, I will get around to it. Feel free to use anything you see here in your own designs or whatever like that. The same goes for the actual programs on the computer. Well, all there is left to it is you guys to build this and to have fun. So, thanks for watching.